two complex solutions. Let's use the quadratic formula to go ahead and find them. First thing we're going to want to do is identify our a, b, and c. Now that is going to be the coefficient of our quadratic term, our linear term, and our constant. And you might look at this and say, there are no coefficients of our quadratic and linear term, but just remember, there's a nice little 1 here, and there's a nice little 1 there, because that's not really changing the problem at all if I insert a 1 there times those variables. But they are going to be very helpful when we're using the quadratic formula. Now, I went ahead and wrote the quadratic formula up here on the video just in case you might have forgotten it. But it's really important to make sure that you know the quadratic formula, or at least have done enough problems using the quadratic formula that you can quickly recall it on your own. And you don't need to be tested on it. You don't need a song or anything crazy like that. You got the quadratic formula down. All right, so now that we've identified our a, b, and c, and again, we did that because this was in standard form set equal to 0. That's really, really important. Make sure you always have that. So now all we're simply going to do is plug these values into our quadratic formula and simplify. Now, a lot of times students will make mistakes on the quadratic formula, and this is simplifying. And again, there's no hard operation here, guys. We're squaring, we're multiplying, and we're subtracting. But guess where students make their mistakes? It's with the negatives, okay? So what I always like to do to try to avoid making mistakes is to find the discriminant first. Now, I already know there's two complex solutions because I did this problem before I made the video, right? And I even told you there's two complex solutions. But let's go and look at the discriminant and understand why there are two complex solutions. The discriminant is what is under the radical. So I already have my values, a, b, and c. Let's go and plug them into the b squared minus 4 times a and see what we get. Okay, so remember I said negatives are where students make mistakes? One way you can avoid making mistakes with negatives is when you are inserting a negative number in for a variable, use parentheses, right? Because if you wrote this as -1 squared, and let's say you typed it into your calculator would give you a -1 because it's going to square it before multiplying by the -1. Anyways, I hope you wouldn't type in -1 squared into your calculator, because -1 squared is just -1 times -1, which we all know is just a positive 1. Now in this case, I have a -4 times a -4. Right? Well, that's going to be, well, -4 times 1 times -4, right? Times 1 here. So that's going to be -16. So therefore, my discriminant here is a -15. Now, that's critically important because the discriminant is what is under our radical. And hopefully, you know, in a real number system, we cannot take the square root of negative numbers. So therefore, a lot of times in Algebra 1, we would just say no solution. But once we start to introduce or learn the complex number system, we recognize we can use imaginary solutions to go ahead and understand the square root of -5. So let's go ahead and do that once we plug everything back into this quadratic formula. All right. So remember I said negatives? Negatives are where students make mistakes. This is not, well, it is negative b. But another way to think about negative b is opposite of b. So a lot of times students will say, oh, it's already a negative b. I already have a -1. So therefore, I'll just keep that as a -1. No, -1 is your coefficient of your linear term. Opposite of b, right, what that represents is the opposite of whatever your b is. So what you're going to plug in your b, you're going to take the opposite of it. So we replace b with a -1 and then take the opposite, which is now going to produce a positive 1. Now, if you remember the square roots of negative numbers, what we can do here is we can say I, which is our imaginary unit, is equal to a -1. The reason why this is important is because I can break up -15 is equal to -1 times 15. Therefore, I can take the square root of -1 and represent it as our imaginary unit I, therefore leaving us with I times the square root of 15. This allows us to go ahead and square root of a negative number with our imaginary unit. So now I can go ahead and replace this with the number I. Okay, so that's perfectly fine as an answer. I love that answer actually in that format. However, on a multiple choice test, for whatever reason, or maybe your teacher might prefer it, sometimes this 2 is distributed to both of them. So what I'm going to do is I'm going to write the answer both ways, so therefore you're not confused. If you see the answer maybe in a textbook or on a test, you know exactly where that answer came from. Take this 2, divide it into the 1 as well as to the I, but remember, we have to do plus as well as the minus. As a 1/2 I square root of 15, and x equals a 1/2 minus a 1/2 I square root of 15. And there you go, ladies and gentlemen. Those are our two complex solutions using the quadratic formula. If you need more help with quadratic formula or solving quadratics in general, then check out the next videos I have for you here. Cheers.